In episode 34 of Mobycast, we dive into part 2 of our micro-series on event-driven architecture. In particular, we discuss a few practical examples used at Kelsus. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
Hello and welcome, Chris and Rich. What a week.
Hi, guys.
Hey.
All right, I'm excited for another episode of Mobycast. I think we'll jump right in because I feel like we started to make some good progress describing event-driven architectures and what they're good for last week, but I want to just get right into how to make them, how we in particular at Kelsus are making them for sort of our size clients, which kind of ranges from startups to clients that need a service into the hundreds of thousands of users. So let's go right into it. So Chris, maybe you can talk just a little bit about how a pub sub design pattern might be implemented at the application level.
Yeah, so pub sub is definitely a very common design pattern, and it can be used, at just about any level of software. A lot of applications and frameworks have this built in as just features of that language to be able to do it. So JavaScript is a great example where the language itself has the concept of events. You can emit events, and then you can set up event listeners that can then subscribe to those events. And so we do this all the time when writing JavaScript applications. JavaScript itself is a very event-driven language because the world of web apps are very event-driven. So, just about anything in a modern JavaScript client application is based upon what's happening in the browser. Like when a page loads, that's an event. When page loading is complete, that's an event, and you can subscribe to that and then do certain things. When a key is pressed on the keyboard, that's an event. So you can set up a subscriber to listen to that event and then take an action when a certain key is pressed. So very, again, just very common design pattern that most developers will be very, very familiar with, and have been used to doing this at the application level. So extending it to the architectural level is really a very straightforward next step of the abstraction, and it should feel very familiar to a lot of folks.
Perfect. Yeah. So I guess we can just go straight there. So do we use the same features of the language in order to extend it to the architecture level, or how do we make that leap?
Right. Yeah. I mean, so here we'll keep the same concepts, but the practicality, the actual mechanics of how it works is definitely different, because you're no longer inside a piece of software. You have to now make those remote procedure calls or some way of talking to other systems typically over a wire, over a network type thing. So, you basically, again, you need the ability to have publishers and subscribers. So publishers are emitting events, subscribers are listening to those events. There are so many different techniques and pieces of architecture you can use to implement this pattern out in the real world. You could do things like use systems like ZeroMQ or even Redis databases to implement pub sub. You can use things like push notifications, whether they be like with the native notifications that Apple has. It's built into its platform, or one of the many other platforms out there that implement push notifications on a more general basis. And then you have things like message queues, and there's so many different platforms. This is a very robust architectural component. Message queues have been a key part of internet architectures now for 20 plus years easily. So
should we go to the project lead or CIO and say, okay, we need 3 weeks to evaluate all the different message queues in order to figure out which one is the best for our project? Or how do we make, since there's so much choice out there, I guess what I'm getting at is, how do we make a decision?
Sure. And this is one of those things where this is the age that we live in, where there's usually many different options out there, many different competing products and solutions and whatnot, and just you end up having to just do it with what feels right for your situation. So as far as message queues go, there's a lot of products out there. There's the do it yourself, host it yourself. You can get it as a as a service. Let someone else run it for you. It can or it can be just built into your actual cloud provider as well. So folks like Amazon and Microsoft Azure and Google Compute Cloud, they all have this is a building block, a fundamental piece of those systems. And so you can get that as a service through that. And so I would say it's for the most part, like take the most integrated path that makes sense for your architecture. If you're building something in AWS and you need message queues, like you'd have to have a good reason not to use SQS, which is their simple queuing service that implements message queues in AWS. Or at least it's one of them. They have they've expanded out. There's a few other ones that have more robust capabilities, but again, you'd have to have a good reason for not using SQS if you're building inside Amazon. Likewise, if you're in Azure, like look at Azure's offering as your go-to before you start thinking about like standing up your own version of ActiveMQ or ZeroMQ or RabbitMQ or any other of the MQ systems that are out there.
Right. And it's like either you're going to use a managed system or you're going to use one that you have to stand up yourself. And if you stand it up yourself, then you are going to have to pay the tax of making sure your computers are running and that they're patched and all that stuff. And if you use the managed system, then you just need to choose one that you trust is going to be there for the duration of your system. So going with some new kid on the block that has an awesome, cool managed queuing service is probably not a good idea. And then, of course, you talked about integration, and your own cloud has definitely done a lot of work to integrate their queuing system with their own services. So go with it. All right, so that's what we use. We use SQS. How do we use it? So let's talk about how that works.
Yeah, so maybe we can get into the kind of the details, the practical example of like doing a pub sub type architecture using things like SQS. And so, kind of like roughly like one of the applications that we have, it's a form-based application. And when forms are filled out, there's certain things that kind of then have to happen after that. And at first it was really just kind of like, okay, when we first built the system, there was just one thing that had to happen. And so really what didn't have a need for an event-driven system. So initially it wasn't. It was just when a form was filled out, then go ahead and do this follow-up task, right? And that was all just kind of part of the one system. Once we got to the situation where it's like, oh, you know what? In addition to that, we also want to do this other thing. So now it was no longer just the one follow-on task, but now there was like these two separate things, and they were really not related at all. That's when it was like, okay, this is now time to do something different, and we need to think about becoming more event-driven. And so, really, what that ended up being is, we've decided to use SNS as our event emitter approach. And then we'll use SQS as a way of receiving those messages, listening to those messages, receiving them, and then acting upon them. And so the way that it works is when one of these forms is filled out, once that's been validated and processed and stored, it then will emit an SNS message to a specific topic. And so SNS, simple notification service, is a way of just broadcasting a message to 0 to N subscribers. So anyone that wants to care about that, they can subscribe to that particular topic. So again, very, very loosely coupled. Your event emitter doesn't have to know who's subscribed to it, or if there's even anyone that's subscribed to it. All it cares about is it just sends a message saying, here here's the message, here's what happened, here's some relevant data about it, and then it can go on its way. So once we had our SNS message being emitted, we'd then wire it up an SQS queue to be a listener to that. And so this is a principle called SNS fan out, where you have one topic and you can fan out to as many different types of subscribers as you want. So you can have things like subscribers can be like Lambda functions if you want. You can wire up an SQS queue to be a listener. You can use SNS to send push notifications to mobile devices like iOS devices or Android devices. So in our particular case, we created an SQS queue to be the recipient of these messages, and then we had that queue subscribe to this particular topic. So that way, what happens is whenever one of these SNS messages are emitted, it basically creates an SQS message on that queue. And so now we have another software component that's basically just a background process that is monitoring its queue. And as messages come in on that queue, it just pulls them off, opens up the envelope, and then performs whatever action it needs to do on them. And so now we have a very extensible system where when we want to do, maybe now we want to go from 2 additional steps to 3, that's just another, perhaps it could be another subscriber to the topic, and it will receive a message as well. And all these things are happening in parallel. It's fanning out, and we have extensibility, and we have the loose coupling. We can rapidly iterate on this.
Hey, this is Rich. Please pardon this quick interruption. We recently passed an internal milestone of 10,000 listens, and I wanted to take a moment to thank you for the support. I was also hoping to encourage you to head on over to iTunes and leave us a review or a rating. Positive feedback and constructive criticism are both incredibly important to us. So give us an idea of how we're doing, and we'll promise to keep publishing new episodes every week. All right, let's dive back in.
So I think, Chris, the thing that I'm having a hard time getting my head around is that it feels like there's 2 message systems involved here, and I don't quite understand why. So why is it that we have to send a message through SNS and then receive it through SQS and then have people subscribe or have functions or whatever subscribe to the SQS system? Why can't we just use SNS or just use SQS?
So this is what gives us the loose coupling, the one-to-many functionality. So we could just make this all SQS, right? We could definitely say, like, when a form is submitted, emit an SQS message, put it onto the queue, and then have something else read off it. And so we could use SQS only. But the problem with that is that you're really in that code, you have to know exactly like what queue you're talking to. And if you then want to extend it to be multiple queues, you'd have to update that code to go right to duplicate that message to each one of the queues that you want it to. So you start getting this more hard coupling going on in the system. So SNS FANA is just really this nice, generic, easy way of just saying, like, I don't want to hard code my subscribers into my event emitter code. Instead, I'm going to have something in the middle that wires this, that glues this stuff up. So outside of my code. And that's what we use SNS fan out for.
So let me make sure I understand. So the code can send a message to SNS. SNS fan out is what enables there to be multiple subscribers. And then the subscribers are the SQS queues. And essentially those SQS queues are just going to store the events until somebody's ready to process them. And that's all they're there for.
Correct.
If we didn't really care about storing the events, could we have subscribers subscribe directly to the SNS fan out topics?
Yeah, like that. I think there's like 8 or 9 different possible types of subscribers that you can have to SNS. So you have different ways of doing it. So you using SQS is good in that it basically guarantees that your software is not going to have to, like, say if it's busy and it's not looking to read the message, or maybe you've rebooted it for some reason, or it's just not running for whatever reason. That message is preserved, and once it is ready to process the message, it can, as opposed to like a real-time fire hose. Like if you're there to get it, you process it, otherwise it gets dropped. Sometimes you want that kind of behavior, and you can definitely do that. It's just in our particular case, like this is definitely like we want it to take a very specific action when this happens, and make sure that it happens.
Right. So just so I can characterize it, SNS is for the pub sub, so the publish and let there be different subscribers. So it's for the decoupling and the pub sub part of it. And SQS is for the making sure we store the events that happen so that they all get processed, and also for making sure that they get processed in the order that they came in, right?
Yes, and then just with a slight caveat, is the ordering is not necessarily guaranteed. And there actually is. There's a way you actually get your choice in AWS. There are ways of guaranteed delivery, and there's other queues that don't guarantee that. So it just depends on what your requirements are. In a lot of the cases, we don't care, right? We don't care if like Form A was submitted first or Form B was submitted. We just care about doing the follow-up actions on each one of them independently. So we don't care.
Yeah, making sure that they get done and not dropped.
Yeah.
Right on. Well, that sounds pretty straightforward. I just because I want to make sure that this episode is topical and recent, I did see, and you might not recall, but I did see that AWS within the last 3 or 4 weeks added a new feature on either SNS or SQS, and it was the ability to attach Lambda functions directly. And I think it was on SNS. It was something where everyone was like, finally, like, why wasn't this a feature from day one kind of thing? Do you happen to remember what that one was?
Yeah, I mean, so it's now Lambda can be a subscriber to an SNS topic. So the way that, and again, the way that we do, and we do it this way just because for some other reasons as well. But in order to process like those SQS, so you fan out to SQS, and you need to then process it. So you need some code to do that. So it ends up being like you write another piece of software. It's a background service, like a daemon type job. You need to write the software. You need to deploy it, maintain it, and make sure it's up and running. And so there's a fair amount of lifting there to get that piece in place, right? You don't get it for free. And versus now with, and so basically, and what the feature is that Lambda can now subscribe to SQS. So it's not SNS, it's SQS. So what it means is now instead of having to go write a piece of code and host it yourself to be an SQS worker, if your worker fits inside of a Lambda function and that makes sense for it in that environment, you no longer have to worry about servers and deploying that code, right? That code and doing the infrastructure for it. Instead, you can just have your Lambda function. You can then set that up to read from the SQS queue that you're pushing these events to, and then you're completely serverless. Which
that's huge, especially for events that might be kind of sparse, where they happen a few times an hour or that kind of thing. Times a minute.
Yep. Yeah, absolutely.
Very cool. All right. Well, once again, we're out of time. I could definitely talk about this for another hour, but I suppose we'll save it for next week. Talk to you next week.
Great. Thanks, guys. Take care. See ya.
Thanks, Rich. Thanks, Chris.
All right.
Bye.
Bye.
Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/34. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.